I'm going to solve this system of equations 3 different ways. The assignment tells me to do this graphically, so I'm going to find my intercept for this line, use my slope, it's positive, so up 3 and over 2, 1, 2, 3, over 2, up 3 and over 2, up 3 and over 2, forever and ever, and I have first line drawn. Second line is not in slope-intercept form, so I'll move this x to the other side, write it in the right order, and I've got an intercept at positive 6 and a negative 1 over 1 slope. The number in front of that x is a 1, so up 1 over 1, up 1 over 1, up 1 over 1, making sure it runs negatively. And here's my intersection. My point of intersection is at 4, 2. So it's done graphically. The second method I'm going to use is the elimination method. And I want them stacked up where the y's are over the y's, the x's are over the x's, and the constants are over the constants. So I want the equation in standard form like this one. So I'm going to write that one over here. And then I need to manipulate this one so that it looks like that. I'm going to subtract 3 halves x from both sides of the equation. So I'll say y minus 3 over 2x equals, and of course, it'll go away from that side, or disappear, vanish, whatever you want to say. And I don't have that in the same order as this one, so I'm going to switch this to y plus x. Just so I've got the x's and y's lined up correctly. Now for the elimination method, I need opposite coefficients, and I have a positive y on both of them, so I'll just multiply this entire equation. Sorry about that, Mel, not your fault or mine. That'll change the signs on everything. So this positive y becomes negative, this negative 3 halves becomes positive, and this negative 4 over here becomes positive also. Now I can combine the equations. 6 plus 4 is 10. X plus 3 halves x, that's 1x, which is the same as 2 over 2, so 5 halves x equals 10. The y's disappear. Use our multiplicative inverse to get a 1 in front of that x. That's always our goal. So multiply this side by 2 over 5 also. And if the 2's cancel, the 5's cancel, that's gone. X equals 20 over 5, which equals 4. Just like we had when we did it graphically. Now that we know that the x is 4, we would put that into whichever equation looks easier. I say that one looks incredibly easy to put a 4 into. Of course, our y would be 2, which is exactly what we got when we did this graphically. This program limits me to 5 minutes, so I'm going to do the substitution method on the next video.